Section 4.3 is about logarithms. So, if you're wondering what in the world is logarithm, the best way that I can tell you what it is that a logarithmic function is the inverse of an exponential function. Okay? So, any function that is one-to-one will have an inverse function. Okay, so for example, you have if f of x was x cubed, then the inverse function would be the cubed root of x, right? And if, let's say, you had x plus 5 was your function, then x minus 5 would be your inverse. If you had 5x was your function, then x divided by 5 would be your inverse function. Okay, so when you have, say, x raised to the 5th power, oh, sorry, not x raised to the 5th power. What I meant was more like 5 to the x. So if you have 5 to the x, then your inverse would be log base 5 of x. Okay? So logarithms are the inverse function to exponential functions. All right? And so you need to have that inverse operation so that you could solve an exponential function, for example. Just like if you had an equation where you had x plus 5, well, you would subtract 5 to solve that. Or if you had 5x, you divide by 5 to solve that, right? So in order to solve an equation, you need to have that inverse operation to use. So if you've got 5 to the x, in order to solve that, technically you need the inverse operation, which is a log base 5. Okay, so that is what a logarithm is for. All right, so you've got, for example, f of x equals log base b of x. Okay, so let's see. Now, when I was talking about exponentials, I didn't give this little spiel about, you need to write things neatly. So that's true for exponentials and for logs. All right, so if you need to write a little bit bigger to accommodate that, go ahead and do that. All right, so for example, okay, the word log is short for logarithm. So that would be like your normal sized font on your normal line of text. All right. And then the base is a smaller sized font. It's a subscript. So it's smaller and it's dropped down below the regular line of text. All right. And then the argument, so whatever the log is applied to, that's also regular size on a regular line of text. Okay. When you have an exponential function, your base is normal size and it's on the normal line, and the exponent is a smaller superscript. Okay. So I just have a pet peeve of a lot of times I'll see students write, instead of log base 5 of x, they would write this, which has a completely different meaning. Okay. From log base 5 of x. All right. Okay. All right. So the base always has to be a positive number that's greater than 0. And so because of the fact that logs are the inverse of the exponential function, so when we talked about inverses, like I said, is you basically just switch your x and y. So this table is the same as my table for exponentials, except for I just swap the columns. Okay, so to me, it's easier to remember exponential function and this table because it's just a little bit more familiar. Like we know b to the power of 1 equals b and all that. So I would say, you know, you can remember this table because it makes a little bit more sense and it should be a little bit more familiar. And then once you know that, you just switch the columns of that table to get the log table. Okay. So everything is just switched between the logs and the exponentials. Let's see, there's a little typo here, which I still call it a typo even though it's handwritten. The range, so like see the domain and range are switched. So see, you've got the domain and range for the exponential function here, and then you just switch those to get the domain and range of the log function. And exponential has a horizontal asymptote at y equals 0. Logarithm has a vertical asymptote at x equals 0. Okay, so all the x and y stuff is all just reversed. All right. And that's what the graph looks like, which also looks like a reflection of the exponential function over the line of y equals x. Okay, just like we talked about for inverse functions. All right. So let's go ahead and do a graph. So number 1, y equals log base 4 of x. All right, so the table so we'd have 1, 0, and then the base is 4, so that'd be 4, 1. And then again with the fraction, I mean, I usually don't even like to bother with that, but I guess we probably should because I do see that on my Labs Plus. They make you put that on the table. And then that's our asymptote. So another thing just that I think about when I'm making my tables is